Hi guys! Today we're going to talk about binomial expansion, but we're going to expand in a little bit of a different way. So using Pascal's triangle is wonderful, and it's a great way to find the coefficients for the expansion. However, when you get really big exponents, like maybe your binomials to the 30th or the 50th or something like that, that would be really long to go through and find the entire Pascal's triangle all the way to the 50th line. That would take forever. So there's a better way to do that. We're going to use something called the choose function. So before I go through this, I just want to explain to you what the choose function is. So first of all, it's right here. If you click on math, oops, let me clear that. First, you're going to click on math, and then you're going to go over to the right until you get to prob. And then if you see the NCR, that's what you're going to use. All right? So what does choose actually mean? So what it means is if you were in a situation where it's NCR, so maybe you had 5 options and you had to choose 2 things of those 5 options. So maybe there are 5 toppings for a pizza and you get to choose 2. So 5 choose 2. The answer to that would be how many different combinations do I have that I could have of these 5 toppings and I choose 2 toppings? How many different combinations of toppings could I have for that pizza? So basically, that's what our choose function means. Okay, so it's out of this many, choose this many. So I just want you to know that's where the probability is coming in right here and why we say choose, because really it doesn't have a connection to really what we're talking about right now. Anyways, so this choose function, that can help us find the coefficient to a specific term inside the expansion. So if I want to go through and find just one specific term where x is to a certain power, and I want to find the coefficient for that guy, that's what's going to be able to help me find it. IB kids, just a quick throwing it out there. IB notation has it in a little bit of a different way. The N is a superscript instead of a subscript. I've never seen that before outside of IB, so if you don't plan on studying outside of the United States, I don't think you'll have to worry about that too much. But, I just wanted you to know that's how it'll look in your formula notebook. So first of all, let's go through and put these into our calculator and see where is this coming from. So with a 7 on top and a 0 on the bottom, that's basically the same thing as 7 choose 0. 7 on the top, 1 on the bottom, that's a 7 choose 1. 7 choose 2. 7 choose 3. 7 choose 4. 7 choose 5. 7 choose 6. 7 choose 7. Okay, cool. So if we go through and think about this, now we're also going to put it into our calculator, but I want you to think about this logically. If I have 7 objects and I need to pick 0 of them, how many different ways are there to pick 0 of those objects? There's only one way, 0. Now let's double check that that's right. So I'm going to go to math, and then when I have that right here, I'm going to put in 7 for my first blank and 0 for my second blank. So it'll look like that. And then we'll press enter. And what do you know? It's 1. If I have 7 objects and I need to choose just one, how many different ways can I choose one object? Well, there's 7 different objects, so there's 7 different ways to choose one of them, right? Now let's double check that that's right. Since I have to keep doing this over and over and over, I always press second entry to get what I just inputted a moment ago. And then I'm just going to go ahead and change that 0 to a 1. You can redo the whole thing if you'd like to. It's just time consuming. And I'm going to find out that it indeed is 7. Now, if there are 7 objects and I need to choose 2 of them, how many different ways are there to do that? Well, honestly, if I needed to go through and do that, I would have to start like making a chart and grouping things together. If I did this without math, would have to kind of draw out my sample space, if you will. So I'm just going to go ahead and use my calculator for the rest of these, and I hope you do too. So I'm just going to sit here and write down my answers. I hope you do the same thing, and we'll check back together here in just a second. All right. So maybe you ended up with these same values. You should. 1, 7, 21, 35, 35, 21, 7, 1. Does this look familiar to you? Does it look similar to anything? That's the 7th row of Pascal's triangle. So we can see that this choose function for each term is going to give us our coefficient before we simplify. All right? So here is our binomial theorem. So when I have a binomial to a power, my first term is going to be that power choose 0, the first term to the power on your exponent, or power on your binomial. Power on your binomial choose 1, and so on and so forth. Here's some things I want you to notice. The number on the bottom matches the power on B. The number on the bottom matches the power on B. The number on the bottom matches the power on B. The number on the bottom matches the power on B. I'm going to say that a few more times. The power on the bottom matches the power on B. The power on the bottom matches the power on B. Okay, so also, another thing to remember right here, they put it as a to the n minus r and b to the r. Just remember that those two powers right there have to add up to n. So the two powers on a and b have to add to the power on the binomial. Okay, so each term of the binomial expansion is n choose r of a to the n minus r, b to the r. All right, and remember, n is the power on the binomial. Cool. So let's go through and find some of these guys. So we want to find the 7th term of the expansion. So there's one thing I want to show you real quick. Remember, the first term of my expansion had a 0 right there, right? For that bottom number. The second term had a 1 right here. The third term had a 2 right here. So when I go through and try to find the 7th term, that means I need to be making sure that I am choosing 6 down here, because that always needs to be 1 less than the term number. Good deal. And then the power on my binomial goes up at the top, 30. And then I'll have a to some power, b to some power. Now remember, the number on the bottom matches the power on b. So my number on the bottom here is 6. So my power on B is 6. And then I know that the powers of A and B are supposed to add up to my power on the binomial. So what plus 6 gives me 30? 24. So A has to be to the 24th power. So now I'm going to go through and solve what I need to. So this guy right here is really 30, choose 6. And whatever that number is, I'll take that times A to the 24th, B to the 6th. So now I'll put that into my calculator. I'll go ahead and click Math, go over to Prob, down to 3, and put in 30 and 6, and press Enter. So we will get 593,775 for that coefficient. And then we have A to the 24th, B to the 6th. Let's try the next one. We want to find the term that contains A to the 5th in the expansion of 2x plus y to the 20th. So first of all, I know I'm going to have these parentheses, and I know that the power on my binomial always goes up there on top. So I'm going to have a 20 right here. I'm not sure what number is going to go on the bottom quite yet, but I know I can figure it out. Now I'm going to take that 2x power, or that 2x term. Now I want to have x to the 5th, right? So I know that that power needs to be to the 5th. And remember to put parentheses around that 2x, so that way you take that 5 to both the 2 and the x. Cool. Then I'm going to have my b term, which is y. And I know that these two powers need to add up to the power on my binomial. So 5 plus what is 20? 15. So I know y has to be to the 15th power. Now we also know that the bottom matches my power on b. So y is my b, the power on b is 15, so that means that down here has to be a 15. Cool, let's rewrite it in a different way. So this is really 20, choose 15 times, and then remember that 5 is going to be, that power 5 is going to go to both of those things, so I'm going to have times 2 to the 5th times x to the 5th. And then we still had y to the 15th. Now if you want to put 20 choose 15 times 2 to the 5th in your calculator all together, absolutely feel free. However, I'm going to go through each little piece to make sure that we're both getting the same values, just in case you might be getting something different so we can figure out where exactly you're going wrong, just because we can't be there in person right now, which breaks my heart. I miss you so much. Anyways, okay, so first of all, we need 20 choose 15. So I'll put in 20 choose 15. And I got 15,504. And we'll take that times, then we have 2 to the 5th. 2 to the 5th is 32. Oopsies, 32, there we go. And then we have x to the 5th, y to the 15th. Now we'll go ahead and multiply those two values together. 15,504 times 32. So we'll end up with 469,128 x to the 5th, y to the 15th. So you can see why we would absolutely, trying to do this with Pascal's triangle, I would never want to do that. love on your calculator. IB kids, the exam loves these types of questions. So expect at the beginning of the school year that you are going to be drilled to death on this. I expect you to be very, very good at this. Let's try a few more. So in x minus 2y to the 12th, find the term that contains y squared. So I like to set up the bones. First of all, I know I'm going to have some parentheses here, and I know that the top number is always the power on my binomial. The power on my binomial here is 12. I don't know what number is going to have to go on the bottom. I'll get there in a second. X is my A term. I'm not quite sure what power he's going to be 2 yet, so I'll hang on for that. Negative 2y is my B term. Make sure you keep that negative with it, and make sure you put parentheses around the negative in your calculator. Remember, when you square a negative number, that turns out positive, so it's really important that you use your parentheses. Okay, so we know that we want y squared for our answer, right? So that means that right here, I need to make sure, calculator down, Mrs. Davis, that right here, I make sure that I take y to the second power. Fantastic. Now I know that the powers of a and b are supposed to add to the power on my binomial. So 2 plus what gives me 12? That would have to be 10. The number on the bottom always matches the power on B. The power on B is 2, so that means I have a 2 down here. Let's rewrite this now. I have 12, choose 2, times x to the 10th, times, and then negative 2 needs to be in parentheses, he'll be squared, times y squared. Cool. So first of all, we need to find 12, choose 2, and I got 66, times, and then if I take negative 2 and I square it, that's positive 4, and then we have an x to the 10th, y to the 12th. So then we'll take 66 times 4 and end up with 264 x to the 10th, y squared. Good deal. In 3x plus y to the 13th, find the term that contains y to the 8th. All right, so I know that the top number has to match my power on the binomial, so that'll be a 13. 3x needs to be taken to some power, but I'm not sure what it is yet. And y needs to be taken to some power. My problem says that y needs to be taken to the 8th power. I know that the powers on a and b need to add up to the power on the binomial. So 8 plus what is 13? That'll be 5. I know that the power on the bottom matches the power on b. So if that's 8, that means that down here, this also has to be 8. Fantastic. So let's rewrite this. This is really 13, choose 8, times, and then remember this 5 needs to go to both the 3 and the x, so I'll have times 3 to the 5th times x to the 5th times y to the 8th. So now let's go through and find these values. So we're going to find 13, choose 8, which is 1,287 times 3 to the 5th is 243. And then we have x to the 5th, y to the 8th. We'll multiply these numbers together. Times 243. 312,741. X to the 5th, y to the 8th. All right, so that's it for this unit. We are going to review a little bit more. Seniors, we're going to say goodbye to you, and you'll be getting a little message from me in the coming days. But I wanted to say that I miss all of you guys so much. I'll try to do a little bit more with maybe some limits and stuff like that to get you ready for next year. I miss you guys so much. I hope that you're doing all right. We'll see you later.